The mainsail. The mainsail is the primary engine of every sailing vessel that carries one, and the sail every other sail exists to support. On the modern Bermuda rig, it forms a tall triangle, attached at its front edge to the mast and along its bottom edge to the boom, giving a sailor two axes of control no other sail provides. Tighten the backstay and the mast bends, flattening the sail's curve and shedding power in a heavy gust. Release it and the sail deepens, driving the boat forward with maximum force. The tension on a large racing mainsail can exceed 15,000 kilograms, roughly the weight of 3 adult African elephants on a single rope. The sail area on a racing IMOCA 60 runs between 111 and 167 square meters of laminated carbon fiber, and the carbon masts on the largest superyacht rigs reached 91 meters above the waterline. When the rig is overloaded and the boat pins on its side, the boom sweeps across the deck at head height. Early versions were called Marconi rigs in the America's Cup because the tall, slender masts resembled radio towers, and several buckled under loads nobody had calculated for. The crab claw. The crab claw is the oldest high-performance sail in existence, and aerodynamic research has shown it outperforms modern Western rigs on a downwind reach by up to 90%. It is a triangular canvas supported by 2 curved spars that arc away from the mast and converge at a forward point. Where a Bermuda sail generates lift by coaxing air smoothly over a curved surface, the crab claw's sharp spar edges create spinning columns of low-pressure air called vortices that drag the sail forward with a force growing stronger as the wind angle increases. Research puts its lift-to-drag ratio between 4.0 and 5.5 on a traditional outrigger and above 6.5 on a modern high-performance proa. The sail enabled the settlement of the Pacific Islands, carried across thousands of ocean miles on vessels built from materials repairable with pandanus leaves and coconut fiber. The hokulea, a traditional Hawaiian double-hulled canoe with a crab claw sail spanning 50 square meters, completed a voyage from Hawaii to Tahiti in 1976, navigating by stars, ocean swells, and bird patterns alone. Western observers in the 1740s recorded astonishment at the speed of these vessels without being able to explain it. The square sail. The square sail is the reason the world was mapped. It is a quadrilateral panel of canvas hung from a horizontal yard mounted at its center to the mast, and when the wind comes from behind or to the side, nothing in maritime history moved cargo across ocean distances more efficiently. A fully rigged clipper like the Lightning carried up to 2,800 square meters of canvas across 35 to 40 separate sails and required between 40 and 60 trained men to operate. She reached 21 knots in the Southern Ocean in 1854, a speed unbeaten by a commercial sailing vessel for over a century. The fundamental limitation is upwind. A square rigger cannot point closer than 70 degrees to the wind without stalling, and tacking required the entire crew hauling yards around while the ship slowed nearly to a stop. Captains waited for favorable winds rather than fight them, which is why the trade wind routes across the Atlantic and Pacific were engineered into cargo schedules rather than simply charted. The yards on a large clipper measured up to 29 meters across, built from multiple joined timber sections, because no single tree grew long enough. The junk sail. The junk sail is the most seaman-like rig ever developed for short-handed offshore sailing, built around a reefing system requiring no crew member to leave the cockpit regardless of conditions. The sail is divided into horizontal panels by full-width battens running edge to edge, and when the wind strengthens, those battens stack under gravity like the slats of a Venetian blind, dropping in controlled sequence on a single cockpit line. The battens also hold the sail in a defined aerodynamic shape in conditions where an unbattened sail collapses into an unusable bundle. Traditional battens were bamboo. Modern retrofits use carbon fiber or PVC pipe. The rig requires no standing rigging, removing a significant category of offshore mechanical failure entirely. Chinese merchants dominated the maritime trade of the South China Sea for centuries, using this design on vessels far larger than anything Europeans were sailing at the same period. Single and double-handed sailors have since completed circumnavigations on junk-rigged boats, relying on the cockpit reefing system during storms that would have required a full crew on a conventional rig. The storm jib. The storm jib is the smallest and heaviest sail on a well-equipped offshore boat, carried exclusively for conditions severe enough to destroy everything else. It is typically no larger than 10 to 20% of the normal headsail area, built from fabric between 340 and 425 grams per square meter compared to the 180 grams of a standard jib, with triple stitching at every seam. In winds above 40 knots, any sail generating significant forward drive pulls the boat onto its side. The storm jib provides just enough area to keep the bow angled to the waves and prevent the hull from lying broadside to breaking seas. During the 1979 Fastnet race, sustained winds of 60 knots sank 5 boats and killed 15 people. Post-race analysis found that vessels most likely to survive had reduced to a storm jib rather than attempting to maintain speed. The sail is dyed high visibility orange, so crew can locate it in a wet locker, and rescuers can identify a vessel in distress from distance. Offshore racing governing bodies treat it as safety equipment and mandate it aboard any vessel entering offshore competition. The spinnaker. The spinnaker is the fastest downwind sail ever put on a recreational vessel, and the most dangerous one to handle badly. It is a billowing, balloon-shaped sail deployed from the bow for downwind sailing, made from nylon so light it weighs less than a shirt per square meter. A superyacht spinnaker can cover more than 2,300 square meters and requires a coordinated crew to hoist, trim, and recover it because losing control is immediate and violent. When the wind shifts and the sail fills on the wrong side, the boat broaches, rounding up into the wind at 40 degrees with the rudder unable to correct. The symmetrical version works on drag, holding a wall of fabric against the wind to push from behind. The asymmetrical version generates lift, which is why America's Cup multi-hulls have recorded speeds above 50 knots on downwind legs. The sail first appeared on the Thames in the 1860s, was described in a sailing magazine as a monstrosity of canvas, and within a decade, every serious racing yacht in England carried one, because the downwind speed advantage over any previous configuration was too large to ignore. The lateen. The lateen is the sail that made navigating against the wind economically viable and changed Mediterranean trade for 14 centuries. It is a triangular sail set on a single long yard, mounted at an angle to the mast, requiring fewer spars, less cordage, and a smaller crew than the square-rigged vessels it displaced. The lateen can point to within approximately 60 degrees of the wind compared to the 70-degree minimum of a square rig, meaning a coastal trader no longer had to wait weeks for a seasonal wind shift to make a return voyage viable. Arab traders carried the design into the Indian Ocean, where it became the characteristic rig of the dhow, still in commercial use today. The triangular sail on the forward mast of the Portuguese caravels that charted the African coastline in the 15th century was a lateen, selected for its upwind performance in the unpredictable winds of the West African coast. The felucca boats on the Nile still carry it today, the yard tilted at its characteristic steep angle, structurally unchanged from the vessels that once supplied Constantinople. The wing sail. The wing sail is the fastest sail ever raced on water, a rigid aerospace structure that replaced cloth with composite materials and redefined what a sailing vessel could do. It functions as a multi-element airplane wing with a trailing flap canted to generate extreme lift at low speeds and flattened to reduce drag at high speed. Unlike cloth, it does not distort under load, so its aerodynamic shape is consistent at any wind velocity. The AC-72 catamarans, carrying wing sails over 40 meters tall, recorded speeds above 45 knots during the 2013 America's Cup in San Francisco. Its competitive debut came in 1988, when a U.S. syndicate defending the Cup arrived with a rigid 33-meter carbon fiber wing on a catamaran, won by 18 minutes across 2 legs and permanently divided the Cup's history. The same principle now operates in commercial shipping through the SkySail system, which deploys a 160 square meter kite at 300 meters altitude. That kite generates traction equivalent to the thrust of an Airbus A318 engine and reduces fuel consumption on a cargo vessel by between 10 and 35% on suitable routes. The jib. The jib is the second sail on almost every modern sailing vessel, and the one that determines whether the entire rig is working efficiently or fighting itself. It is a triangular head sail attached to the forestay, running from the bow to the top of the mast, and its most consequential function is not generating drive, but controlling the airflow over the mainsail behind it. The gap between the jib's trailing edge and the mainsail's leading edge is called the slot. A correctly trimmed jib accelerates air through that gap, keeping airflow attached to the leeward side of the mainsail and preventing it from stalling. Both sails produce more power together than either does independently. Modern racing jibs are built from carbon fiber laminates engineered to hold their aerodynamic shape under 1,360 kilograms of load, because a jib that distorts under pressure deforms the slot and costs the boat upwind distance on every tack. The classification system runs from a full-size number 1 down to a heavy air number 4, each cut for a specific wind range, and selecting the wrong sail for the conditions costs more speed than almost any other mistake a crew can make. The Genoa. The Genoa is the largest headsail carried on a standard cruising or racing yacht, and the sail that defines light air performance across the fleet. It is an overlapping headsail whose foot extends past the mast, with a 150% Genoa having a foot length 1.5 times the distance from the forestay to the mast. In 1926, Swedish sailor Sven Salin exploited a gap in the rating rules at a regatta in Genoa, Italy, fitting an oversized overlapping jib that added 40% more sail area without increasing his rating. Race committees had not anticipated the geometry, and within years, the overlapping headsail was standard across competitive fleets worldwide. On a cruising yacht, in light winds, the difference between a working jib and a large Genoa is the difference between moving and drifting. A 150% Genoa on a 12-meter yacht covers roughly 55 square meters, and tacking it requires feeding the sail around the forestay before it fills on the wrong side. Experienced crews complete the maneuver in under 10 seconds.